Hello, this is Dr. Michael W. Berry, and I'll be offering Computer Science 370 this semester. The lectures for the semester will be provided online, hosted on iTunes U, and the instructions on how to access the videos will be provided on the Blackboard account for this course. All the questions and answers related to material in the course from assignments, and lecture material and any other general questions will be handled through the piazza.com page for Computer Science 370. So make sure that you are registered on that. And again, you can send me email if you need access to piazza.com. You should get an invitation email on how to join that. The book we're using for this course is called Numerical Methods in Engineering with Python 3, as you see on the screen with the big green snake. It's written by Jan Kusalis, and the publisher is Cambridge University Press. The book is available from the bookstore, alternatively from other book vendors online. And what you're seeing on the screen is actually the ebook version of it. ebooks.com provides an electronic version of the textbook with what's called an Amigo reader interface for it. It's very nice, as illustrated here. Here's the Contents tab. Lots of nice features are available in terms of immediately going to the material of the book that you need to look up things, make bookmarks and notes, and so forth. Very, very nice. I'll be using the ebook version to supplement some of the lecture notes and materials as we go through. Let's talk about the notes. So I'm going to bring up the first set of notes here for the course. All the lecture notes will be provided on Blackboard for you to download and to follow along and annotate, perhaps, as I provide more information than what is on the slides. I'm trying to use the slides as outlines for us to discuss and to as we work through all this material. So I'm going to go ahead and get started and cover some of the intro material out of Chapter 1. I won't cover all of Chapter 1 in this video. I'll try to keep these videos smaller for download purposes and try to break the material up very easily so you can easily go back and review very specific topics. Python is a wonderful language that I think you'll enjoy learning this semester for scientific computing, but also to use for other projects and for future work, perhaps even in your senior design. So it's an interpreted language, and a great reference website for the language is indicated on the screen here is www.python.org. That has general reference information about all the different libraries and functions that are available. And most of the material, most of the functions will be described in the lectures or in the book, but it's nice to know that there's a place on the web that you can go for a complete reference. The language does have an editor that's available that you can interactively create programs and execute them and change them and debug them, and it's called idle. I don't particularly use it. I'm more comfortable just creating script files with the commands and then just executing the script files. Your TA will show you and demonstrate idle, but it will also show you how to create script files and run Python on your desktop or laptop computer. You will need to make sure that you're using NumPy, which is a particular scientific library provided with Python. There's many functions that we'll be using through the semester, and again, we'll make sure you know how to access that. We are using Python 3. There are earlier versions of Python, but you'll want to make sure you're using Python 3. And so if you're downloading, if you don't already have Python, make sure that you are accessing Python 3, some version of Python 3. And again, what's indicated here at the very end of the file here is the fact that script files can be used, which contain the commands to be executed, rather than running Python interactively. And if you do that, then you have to tell the operating system, Linux operating, for example, that you are executing a Python script. And so the first line of that script file would need to be a pound sign followed by the exclamation, and then the Unix path, the Linux path, to the interpreter. And this is an illustration of the path on one of my Mac laptops in terms of where Python, in this case I'll be running 3.3, exists. So again, your TA will demonstrate how you can run script files, and I think you'll find it very convenient and very natural in terms of how to write and execute programs. So starting the core material in Python, this is section 2 of the first chapter of the book, starts off by describing basic variables and data structures that make this language a little bit unique to maybe what you've seen in C and C++ and Java and perhaps some other scripting languages. First of all, the most important thing is the nature of variables. In Python, variables are dynamically typed, and you have to pay attention to how you define literals. So for example, first thing I want to point out is that what you see on the screen in terms of these greater than signs, that's indicating a prompt for the Python interpreter. So that's what the 3 greater than signs mean on all of these subsequent slides. And then what we're doing to start off with is just very simply defining a variable A to associate with memory to store the integer value 1. So anytime you type an integer in Python, the interpreter automatically interprets that as an integer, because that's really what it is. So the memory associated with the variable A now is storing an integer. The other thing I want to point out here is notice that the syntax here, I've indicated here that I have a pound sign followed by some text. That's a comment. So in your script files or even in the interpreter, if you were to type a pound sign, it would immediately consider that a comment and not execute anything after that. So it's just a nice way of annotating your file. And again, we really do like for you to comment your code. So in this particular example, we've stored 1 in the memory associated with the variable A, and it's an integer. And then if you were to execute the print function, and the syntax is just to print followed by parentheses and then whatever you want to print, the variable there. In this case, it would do pretty much what you would expect. It would print the integer 1, because that's what we've put in that variable. But then notice what happens next in the interpreter. It's an illustration of dynamical typing, because A originally was an integer, and now what we've done is arithmetically added the value 1.5, which is clearly a float and not an integer. So what is A now? A, of course, now is a float, because we have completely changed the meaning of A, that now it has a fractional component. And of course, if you were to print what A is, then you would get the value 2.5, which is clearly not an integer. That is clearly a floating point value. So this is an example of A has originally defined as an integer by defining it to be the literal 1, and now it has become a float. So this is an illustration that variables can dynamically change their types in this language. Strings. Strings are important in many languages, and Python is no exception. Strings are thought of as a sequence of characters. That's nothing new. That's pretty consistent with many languages, such as C. One slight difference is how you can define the sequence of characters. You can do it by single or double quotes, so that is unique with Python. You may see examples on these slides with single quotes, and sometimes maybe you'll see me using double quotes. Whatever you have on the left, you put on the right, but a string is defined by using quote marks, double or single. Don't mix them up. If you start with a single quote, finish with a single quote. Concatenation is possible by the overloading of the plus sign, in the sense that if it recognizes 2 strings on both sides of the plus, that will be interpreted as concatenation, as opposed to an addition of 2 integers or an integer and a float, for example. And then there's the ability to pull off subsequence of characters with the slicing operator. And the slicing operator is the colon. And so this very simple example that we have here is an illustration of defining two strings. One of them will define this, the string variable we'll call str1. It will store the string Fred. And then the second string variable str2 will define Wilma. I guess I'm thinking of the Flintstones here. And so I have two string variables that are defined with those two different strings. And then we execute this print command to illustrate the use of not only print, but the concatenation operator plus. So what we've got here is we're trying to print this for the str1 string, which is Fred, concatenated with a string, which is basically a blank followed by the word A and D and followed by another blank. So in this case what you've got here is 5 characters in the sense that you've got a blank, A and D, and then another blank. So again, if a space character is a character, don't forget that. And then we concatenate it again, the second string str. So I think if you look very carefully, you can see what we're doing here is that we're trying to basically print out the first string, in this case, of course, is Fred, and we would print Fred, and then there would be a space, and then the 3 characters A and D, followed by another space, and then we would have the second string, which is Wilma. So that's what the first print on this slide would produce. Okay, an example of concatenation. And again, that my underline there means space. Now, the second print is an illustration of slicing. Again, your ability to pull off a subsequence of characters from a string can be extremely useful in many applications. But you have to be a little careful how you interpret this colon notation, and so I want to go through this with you. And then the way we interpret it is consistent across all the data structures where we will do slicing. And so in this case we're doing it with strings, but in a little bit you're going to see me talk about the same thing with slicing, but with what's called a tuple. So we have a string 1 which stores Fred. It's a sequence of 4 characters, capital F, R, E, D. And this particular slice here of that string is indicated by a starting position of 0. Right? So what that means is you think of, well, what is the character in position 0? And of course it's what you'd expect it is. It's the capital F here. That is in position 0, and of course you would expect the R to be in position 1, and then E is in 2, and then D is in position 3. But what the slicing operator colon here is indicating is that you would start, this says start in position 0, and then go up to but not include position 2. Some people would call this more like a boundary. Again, let me say that again. That means you go up to but do not include that particular position. So in this case, if I start at 0 and go up to but don't include 2, I would only cover 2 positions. Okay, so that would mean I would cover 0 and then 1. So the only output you're going to see in terms of this slice is the capital F and the little r. So again, we think of the second operand, you could say, for the slice, or what comes to the right of the colon, is a boundary index. Okay, it literally means up to but not including. Now another property of strings as implemented in the Python language is that strings are what we call immutable objects, and they have fixed length. So strings have fixed length. You can't change the length as you define it, and they are immutable. Immutable, of course, means cannot be changed. And so therefore they can't be modified by some other assignment statement. And this is a classic example. Suppose at the Python interpreter prompt we were to find a string called S, and we were to assign it this sentence, my name is John. And of course keep in mind that there are some blanks in there, so it's certainly got the 4 words, but there are these 3 blanks that are included in that. So those are each characters in the sequence. And then what's illustrated next is an attempt to define in position 0, so the character in position 0, to set it equal to capital T. Of course, in the original string, we are looking at the capital N is in position 0. That is the 0th character in the sequence. What happens, as indicated here in the comment? Well, what happens is you would definitely get an error. And the interpreter hopefully would tell you in the message, and we'll see examples of this later, that the string is immutable. It's not allowable. Such assignments are not allowable. Strings are not immutable. Other data structures are mutable, but these are not. So let's move on to another particular data structure. This is the tuple. Similar to strings in some way, but a little bit different. Gives you a little bit more flexibility. This is a sequence of arbitrary objects of various different types, and yet still supported by similar string operations. What's important to realize is the delimiter for tuples are parentheses. So when you see parentheses, you'll be thinking of tuples. Here at the command prompt for the interpreter, we're defining a particular tuple called a record. And again, this might illustrate information about a human's record or a person's record. And you can see clearly here that what we've got here is a tuple with 3 basic objects to it. One is a string, looks like a last name, followed by a first name. And then what's interesting here is we actually have a tuple within a tuple. So this last object, the 3rd object in the record, is actually a tuple itself, and it's representing a date. So it's 3 integers being used to represent a date, which is very common when you think of filling forms out. So that probably represents, and most likely, May 15th, 1975. So again, the objects are separated by commas, so that's very important to realize that you separate the objects by commas, and you can have as many as you want, and they can be all different sort of types, integers, strings, floats, and so forth. Again, very, very useful if you're thinking sort of database kind of applications. And what's really cool is what you can do is you can immediately, having defined the tuple, you can assign labels to the different objects. And that's exactly what this next line is doing here, is we're now assigning a label to each object. And the assignment is done in order, so it matters what comes first in terms of the object that you define and the corresponding label. So in this case, last is going to be associated with Doe, first is going to be associated with John, most likely the first name, and this 3rd tuple, which we said is a representation of a date, in this case it'll be a birth date. Right? And we'll call that label B-date. Right? So basically what the interpreter is now doing is got the capability of creating variables, or I use the word label, but you could see variables now are associated with each part of the tuple record. So if you were actually to print first, right, which is not, in this case, not the first object, it's actually the 2nd object in the record. It's associated with a first name, you would get the output you'd expect. You're expecting to get the first name of this person, which corresponds to the 2nd object in the record tuple, and you'll get John. And then what you see in the next line is assigning another variable. In this case, we're going to call it, like birthday year, or let's just say B year, to be within the B date object, which itself is a tuple, the information or the data, let's just say that's in position 2. And clearly if you go to this particular tuple, which is being, occupying the third object position of record, the 5 is in position 1, the 15 is position, 5 is position 0, 15 position 1, and 75 is in position 2, which clearly is a representation of a year. So now what we can do is we can say, well, the birth year is actually B date bracket 2. It's the object within, it's the object in position 2 of the birth date tuple, which lives inside record. And again, how does it know what B date is? Because it got the position of B date from where it lies in the record tuple. So it's really nested and very, very cool in that way that you can have tuples within tuples. And then, of course, what you'd expect if you were to print B year in this case is you would get the integer 75. If we just keep that example in mind now and then just illustrate the fact that I mentioned earlier that even tuples have arbitrary object types and things, but they do share some of the similar functions that string does, that you can actually concatenate things. In this case, you could define a variable name to be the object in position 1 of record plus a space plus the object in position 0. So if you think about, again, what the meaning of those objects are in terms of their position, Doe is in position 0, John is in position 1. So this is a representation of printing, let me go back, I'm sorry. This is a representation of printing the first name John with a space, I'll indicate it like that, followed by Doe. So again, we're concatenating the space between the other two objects. And that's what you would get for print name. Now, if you were to access a particular object out of the record, in this case indexed at 0, again, you know what that is, we've already said this, that would be fairly simple just to get the last name. So this second print will do nothing but just print Doe. Now the next one is kind of special because now we're getting into that slicing capability, which we saw earlier for strings, but now we're doing it inside tuples. And again, the objects could have different types and so forth. So keep in mind what we said before in terms of how the slicing works with the starting position and then the boundary. So what print record 0:1 it turns out is not the same output as print record 0. This is not a slice up there. That's just a particular object. So for this particular slice, you would get a tuple back. So it will actually print a parentheses to indicate that you're going to get a tuple. It would give you that first object, which is the string Doe, followed by a comma. But because the boundary index here is 1, it can't include the 1, so it just stops and prints a right print. And that may seem strange, but you may want to play with that a little bit to get used to it. But this is an illustration of a tuple with one element. Okay? There's only one element in the tuple, and it's followed by a comma. That's the default. Now the second one actually may make more sense in the sense that, again, this is a tuple which starts off in position 0, which means it would print what it sees in position 0, which is Doe, comma, and then the boundary is 2, which means the boundary is the birthday tuple there, 5, 15, 75. It's not going to get there, but it would get through John. So this would print a tuple. In other words, you would have parentheses, and then inside the parentheses you would have the string Doe and then the string John. So we've had strings and tuples, and now we're going to lists. Lists are very similar to tuples, but they are mutable, and the elements and the length can be changed. And that's very important when you think of the meaning of a list and how you've thought of list and use the sort of list data structures in C and C++. So first thing right off the bat with the interpreter here, you're noticing we're going to define a variable called a list, and it's going to get, notice, square brackets. So keep in mind, strings, single quotes, double quotes, tuples are delineated by parentheses. Lists are delineated by square brackets. Very important, okay? Have to keep this straight. The items within the list separated by commas, and so here's an illustration of a list of 3 floats, okay? Again, because I literally put 0.0, the interpreter will assume that those will occupy a floating point representation in memory. If you're wondering if I had put list equals bracket 1, 2, 3, that would be a list of integers, okay? Because again, it will literally interpret if it has a decimal point or a period there, then it knows to create floating point representations. So, square brackets for list. Lists have really nice built-in functions with them, and they're accessible through the dot operator. In this case, that if you wanted to quickly add another element to the list, you can use the built-in function associated with the list type. So you would just, the interpreter knows that this variable list is a list itself, so it can use the append function for list, and you essentially use it by the dot operator. So you would say list dot append, and then give it whatever you want to append, and then when you printed that list, which indicated here, it's what you would expect. If you printed it, you would have a 1.0 followed by a 2.0 followed by a 3.0. That should have been a comma there. I'll correct that. And then you would have a 4.0 here. Okay. All right. So that's appending. And another nice built-in function is insert. In other words, you'd like to insert something into the list. And this is a built-in function for all lists. And again, whatever the variable of type list is, you would name it, then put dot insert. This will be the position that you're trying to insert it into. And then the object itself that goes in there, in this case 0.0. Right? So if you were to print, if this was in the same program, the list now has 4 elements. It started off with 3, and now you have 4, and now you do the insertion, and you would expect that, okay, if I insert something at position 0, that means it's at the very beginning of the list, and that will be put in there, and then everything else will follow. So you'll have 0, then 1.0, and then 2.0, and then 3.0, and then 4.0. And that would be the end of your list. Okay. So you would have 5 elements in that list. If you needed the length of the list, again, it's very easy to get that in Python. There's a built-in len function for length. Very, very nice. Especially as you're dynamically changing and adding or deleting, and you need to know how long the list is. There's no need to use any type of loop structure. You simply could access it by just passing the list, the name of the variable, in this case list, to the length function. And if I printed the length out for this particular list that we have here, then what we would have is just, what we would have is just 5. So it would print a 5. Okay. Now if we, again, think of slicing, and now we're doing it with list objects in this case. Here's an illustration of mutating, or it's changing. Lists are mutable now. Strings weren't, but lists are. And this is saying that I'm going to change some of the interior of my list, and I'm going to start in position 1, and I'm going to go up to but not including 2, and modify the sublist. And we have to be very careful now on interpreting again this business of starting and the boundary and try to make sense of it for this particular example, which is a list that has these elements in it. So clearly there are 5 elements in this list, and this particular modification is to start in position 1, and you have to think about, all right, if I go to the list, where is position 1? Well, here is position 1. It's actually storing the floating point value representation of 1, which is 1.0. And again, the :2 notation indicates that I will not go past position 2, and position 2 would actually correspond to this particular element, which will not be changed. So 2, 3, and 4 are not going to be touched. So what's really happening here is that I'm actually replacing, this is going to replace that element of the list in position 1 with another list which has 2 elements in it. Again, so the 1:2 notation only really references that 1.0. So if you do the print there, and again, I encourage you to do some examples in Python with this so you can get comfortable with it, is what you would see is the very first element of the list would have been unchanged, so it still would be 0.0. So we'd have a comma. But then what you would see is the fact that the 1.0 has been replaced now with a sublist here, 3.0. And then the rest of the original list is unchanged. 2, and then 3, and then 4. So very interesting. Maybe not as intuitive as you might have thought. But again, it's very important that you think about the meaning of this boundary index when you do slicing in this language. Another very, very important thing is the meaning of the equal operator here when you have a mutable object. So for example, for a mutable object like a list, if you had something like y gets x, in this case, or y equals x, that is not a copy. That is just basically an alias for the original object. It creates another reference to x in this case. So you would have x as, say, a list, and then if you say y equals x, it's still the same list, it just has another name, y. So it's very important that you understand, in this case of mutable objects, that's not a copy. That's not getting separate memory. It's the same memory with basically just another label to it. Okay, very important. If you really wanted to create a separate copy, then what you'd have to use is this very special notation, bracket, colon. Okay? So in this case, if you wanted a new copy of, let's say, x is a list, then z equals x bracket, colon, close bracket, that would actually generate new memory and have the same list copied into it. Okay, so let's do these 2 examples just to illustrate what we're doing here. So if you started with x as a 3-element list of floats, 1.0, 2.0, 3.0, and then you executed y equals x. Again, that's not a copy, that's just another alias. And then let's just say you said y bracket 0 equals 2.0. You're trying to change the element in the 0th position to a 2. And then notice right after it I print x. And so a very novice programmer might think, oh, nothing's really changed. What in fact it has, because remember y is just an alias for x. So what you've really done here in this particular output is you have modified the original list of x, because again y is just a name for it. So the 1 is actually gone. You've actually overridden it totally in this example. Okay. Now, the rest of this example, the interpreter is actually given z to be x bracket colon. So now you generated a copy, which means the small list, the 3-element list, is a copy of it now exists in a different part of memory, and it's referenced by the variable z. And then if you can change z all you want now, it's completely separate. Again, thinking that now the x has this new notation here, or is this new result 2, 2, 3. If you were to print x again, the first element is not 4. It's exactly the same. In other words, x has not been changed here. So because the z is not an alias, that is a separate copy. So the rule of thumb is that if you need a copy, make sure you're using this notation here. And if you are using the equal sign, that is just an alias. Some other representations that can be very helpful in this particular class, because we do linear algebra now and then, is the ability to represent a matrix. And this is an illustration of basically a matrix being a list of lists. Again, you think of the bracket notation for a list, and what's nice is the way this is typed is you actually can see this is a 3 by 3 matrix. It has 3 rows and 3 columns. The rows are 1, 2, 3, 4, 5, 6, and 8, 9. Some syntax you want to pay attention to is, first of all, the fact that the whole representation of the matrix is a list, is that the outer brackets indicate that it is a list. But inside that, what you have are 3 other lists. The lists are separated by commas, and this is a very important character to include. This is telling the interpreter I'm continuing on the next line. So this is continuation. So this is how you represent continuation to the Python interpreter. It's a backslash. Right? And if you type it very nicely, as indicated here, it kind of looks like a matrix, as a human might write it. Okay. So this is one way you could use lists to actually represent a matrix, which we will do at time. And then we just have to make sure we understand the meaning of indexing in this case. So if you go down to this next print statement, and you see print matrix bracket 1, and the question is, okay, I'm not sure I understand. You think of a two-dimensional array or a matrix, and there's a row index and a column index. Well, what does it mean to say print matrix 1? Well, you just keep in mind, what is matrix? Matrix is a list of lists, and so what it's asking for in this case is the list in position in position 1. So for this particular example, the first list is 1, 2, 3. The second list is 4, 5, 6, and the third list is 7, 8, 9. Of course, bracket 1 means second in terms of ordering here. So what you'd actually get here is that second list, 4, 5, 6. You get the second row of the matrix. Now, C programmers don't have a problem with that because of zero indexing. We're very comfortable with that kind of thing. And then the next print, very comparable to what you'd expect from C, that is a particular element of the matrix, so to speak, in terms of bracket 1, bracket 2. But the way it would really be interpreted is that I'm going to access the list in position 1 and then pull off the element of that list in position 2. And so in this case, we're going to get the 6. All right. But if you think about it in terms of just regular indexing of a 2D array, that kind of makes sense. It's in position 1, 2 in terms of the second row, third column. Simple arithmetic operations that are possible is what you'd expect with most languages in terms of adding and subtracting and multiplying and dividing. But there's some others that we need to make sure we understand the meaning of. Certainly in this case, it depends on the data structure. First of all, one thing I do want to point out is that if you have two asterisks, those are exponents. This is how you do exponentiation. And of course, the percent sign here is the modulus. So that's the modulus operator. And again, this is exponents, raising something to another power. Now, sometimes the combinations with strings are kind of interesting. You can do some interesting things in terms of string manipulations, and this is a couple examples that show you the differences between, depends on what the data structure is. So here's an example of a string that's called yada, Y-A-D-A, followed by a space. So this str string variable actually has 5 characters in it. And then if I want to print 3 star str, right? And again, you have to think about now, what does that mean? Because str variable here is a string. It can't be multiplied by 3, but the language designers did a cool thing. It's not multiply, right? It's basically replicate. So this is a way of representing repetition of the string, which is very nice. So what it would do is it would basically generate a particular repetition of the original string. So what does it mean to replicate this string? In this case, what you would get on the output would be the first instance, yada with the space, followed by another yada with the space, followed by another yada by a space. So you'd have yada, yada, yada with spaces following them. So that's what the repetition associated with the star would generate for strings. Again, this is with strings. If you saw the asterisk occurring before a string, it's repetition. Then below is an example of not a string. Now we have a list, and you have a list of 3 integers. The integer 3, 4, 5 that we're assigning that to the variable name a, and then now I do print 3 star a. So here's the difference between the star operator working on a string and now working on a list. So in this case, it's still repetition, but it's repeating the contents of the list. So you would still get a list on the output in this case, but it would be the first instance, 3, 4, 5, followed by another instance, 3, 4, 5. I know this pen is not as clear as I need it to be. Followed by another instance of the list. So that's replication of the list itself. It's 3 times larger than it started with. Okay? And then finally, the plus operator in this case, if we're looking at a list, if we're assuming A is still a list, and if it was the original list, 3, 4, 5, then we could append another list to it and get the list 3, 4, 5, 6, 7. Okay. All right. So that's an illustration of just concatenating 2 lists, if you like. And finally, here's an illustration of maybe indicating some things to be careful about. Let's suppose you had 2 string variables, one called str has yada and a space, and then a second string called str2 was defined as the string 4 space u, and then you were to use the print function and print str plus str2 to indicate that you wanted concatenation. So it perfectly understands how to interpret that plus operator, because both of the operands are the same type. It understands that they're strings, and so it's what you probably would expect. This will be the concatenation of those two strings. So what you would get is yada followed by a space for followed by another space u. Okay? Yada for u. Now, the last example is source of errors, is people not paying attention to the meaning of the operator from the thinking as the interpreter would and say, all right, if I'm told to print 4 plus str2, what is the interpreter supposed to do? How does it overload the plus in this case? Because one operand to the left of the plus is of integer type, and the other on the other side is a string. Think real carefully. It's pretty simple. What's going to happen is this is another error. It's going to throw an exception and say, make up your mind. Either str2 should have been an integer, or maybe you meant to put single or double quotes around the 4. Again, you have to help the interpreter out. It tries to infer types based on what it's seen, again, dynamically typing them. And in this case, they're incompatible for plus. So we're going to stop here at this lecture, and we'll continue on with our introduction to Python next time.